Well, hello students, welcome back to Mathematics class with me, Mr. Alfie. In this video, we're going to learn about addition of probability. Probability A or B equal to probability A plus probability B if event A and event B are mutually exclusive. If event A and event B are not mutually exclusive, so probability of A or B equal to probability of A union B. Before I tell you about mutual exclusive of two events, I want to talk about cards. The first thing about standard deck of cards is there are 52 of them. They divided them up into some groups. For example, there are 26 black cards and there are 26 red cards. The way I have them here, that 26 black cards drawing at top and then 26 red cards drawing at the bottom. A standard deck of cards has 4 suits. They're called clubs, spades, hearts, and diamonds. The clubs and the spades are the black cards and there are 13 of each. And the heart and diamonds are the red cards and there are 13 of each of those. 13 times 4 is 52. There are 12 that called face cards, and if you look at those cards, they actually have faces on them. That is why they're called face card. The J stand for jacks and there are 4 jacks. The Q stand for queens and there are 4 queens, and the K stand for kings and there are 4 kings. So the 12 face on a card are the 4 jacks, the 4 queens, and the 4 kings, and there are 6 black face card and 6 red face card. A standard deck of cards has 4 aces. There are 2 black aces and 2 red aces. The number card 2 through 10, they are called number card. There are 9 number cards of each suit. That means there are 18 black number cards and 18 red number cards. What is mutually exclusive? Two events are mutually exclusive if they cannot occur at the same time. What does that mean? Let's jump to the example from page 106. In rolling a die, let event A 1, 3, 5 and event B 2, 4. This is how we draw event A and event B in Venn diagram. As you can see, A and B are mutually exclusive because they cannot occur at the same time. In other way to say it, there is no common element between A and B, so they are mutually exclusive. So, next example. One card is drawn at random from a deck of 52 playing cards. Event A is a card is black. Event B, the card is a heart. Event C is an ace. Remember, this is a complete deck of 52 cards. So, determine whether each of the following pair of events is mutually exclusive or not. A and B, and then A and C. First, let's talk about A and B. A is B the event that the card is black. This is all the favorable outcomes of event A. And B is that the card is heart. This is all the favorable outcomes for event B. As you can see, there is no common outcomes of A and B. That's why A and B are mutually exclusive. So, how to find the probability A or B? Probability A or B equal to probability A plus probability B. Because they are mutually exclusive, we can add all them together. So, probability of A is actually 26 per 52 because there are 26 favorable outcomes. You can count here per 52, the number of outcomes, the total outcomes. Probability of B is 13 per 52 because there are 13 favorable outcomes and 52 the total outcomes. So probability A or B, remember this is OR, is actually 26 per 52 plus 13 per 52 equal to 3 per 4 in simplest form. How about A and C? We have known this is the all outcomes for A and C. This is the C. Even that the card is an ace, and this is all the possible favorable outcomes for an ace. So as you can see, there are 2 common outcomes, the ace of clubs and the ace of spade. So A and C are not mutually exclusive because they can occur at the same time or they have the common outcomes. So, how to find the probability of A or C? We need to find the outcomes of A union C. This is list of favorable outcomes even A. This is the list of favorable outcomes even C. Remember, like the set, if there are common elements, the unions of two events, you just need to write the common elements once because this is the same with this one. You just need to write it once. Just write it here. So this is all the elements of A union C. There are 28 favorable outcomes of A union C. So since A not mutually exclusive with C, probability A or C equal to probability of A union C. We have known that all the outcomes of A union C is 28, so the probability is 28 per 52 or 7 per 13 for simpler. How about the next case? A vase contains 2 white roses and 2 red roses. 2 roses are drawn one after the other without replacement at random from the vase. Even X is getting white rose at the first take. Even Y is getting both red roses. Even Z is both white roses. Are X and Y mutually exclusive? And are X and Z mutually exclusive? This is all the outcomes that we can find. The X actually in the blue outcomes. The first take is a white. As you can see, all the first take is white. And Y is both red roses. This is the outcomes, only 2. As you can see, between X and Y, there is no common outcome. So X and Y are mutually exclusive. It means we can find the probability X and Y by adding them. The probability of X is 6 per 12. Probability of Y is 2 per 12. So probability of X or Y equal to probability X plus probability of Y because they are mutually exclusive equal to 2 per 3, the probability of X or Y. How about X and Z? We have known this is all the elements of X or the outcomes. And inside the circle is actually element or outcomes of Z, both white. As you can see, X and Z are not mutually exclusive because there are common elements or common outcomes. Which one is the common? This one is common and this one. So we cannot find the probability of X or Z by adding them. We need to find the element of X union Z. This is all the outcomes or the element of X union Z. So probability X or Z equal to probability X union Z equal to 6 per 12 or equal to a half. How about this example? A club holds an election for the post of chairperson. The probability that the candidates Monica and Roland will be elected are 0.36 and 0.47 respectively. Find the probability that A, either Monica or Roland will be elected. The first thing that we need to notice is, are these two events mutually exclusive? They are actually mutually exclusive. Why, sir? Because the probability Monica and Roland will be elected cannot occur at the same time. If Monica elected as a chairman, so Roland is not. If Roland is elected be a chairperson, Monica is not. That's why we call cannot occur at the same time. Either Monica or Roland, one of them. Probability Monica or Roland will be elected equal to probability Monica plus probability Roland will be elected. We know all the probability of Monica and Roland, so the probability of Monica or Roland will be elected is 0.83. Next, find the probability that neither Monica or Roland will be elected. Nor means none of them, because none of Monica nor Roland will be elected is actually 1 minus probability of Monica or Roland, we have found the probability Monica or Roland is 0.83. So the probability of Monica nor Roland will be elected is actually 0.17.